And that's where we'll pause here. And there are some things that they just said that you probably need to understand if we fully want to know all about circles. And they might be a little bit of review, but at the top there, a couple things they said. First, a circle is the set of all points in a plane that are the same, did you catch that?
Distance.
The same distance. Very good. So we're talking about how far away from the center point is a circle. Well, distance. They got to be the same distance away from a given point. And that point that's in the middle is, well, I guess appropriately named the center point. By the way, if you wanted to name a circle, whatever the name of the center point is, like let's say it was point C, then we would actually call that circle Circle C. That's how you name a circle, by its center point. Okay?
Yeah. He made that little joke, circle A.
I'm sorry?
I like Tim made that little joke about circle A.
Yeah, just like that one. Yep. So the other one, a line segment with one endpoint at the center of the circle and the other endpoint on the circle is called your radius. Now this would be your radius, I'm guessing by the image. Think about standing at the edge of a pond and throwing a rock right in the center. The distance from the edge, the outer edge, to the exact middle, well, that's your radius. And you already told us that the radius is smaller than the diameter. So if we look at a segment that passes, a line segment that passes through the center of the circle and has both endpoints on the circle, so we're talking about now here all the way through, that is your diameter. Picture a bridge that goes over a pond, all right? All the way from one edge through the center to the other. That's your diameter. And you guys are really good at this already. This is a good review from last year a little bit. The length of the diameter, like you said, if the radius is 4, what's the diameter?
8.
Jack? 8. It's 8. So what do we say about the length of the diameter? It is, how would you say times 2, but in one word? Twice. Yeah. It is twice the length of the radius. So finally, we can call the distance around a circle the circumference. Now, just so you know, yesterday was perimeter. And perimeter was the distance around a polygon. Well, the problem with a circle, it's not a polygon. It doesn't have sides like line segments. It has one continual, basically, arc, they said, that goes on all the way around. So that's why we have a new name, really, circumference. We don't call it perimeter of a circle. It's a circumference. And you probably picked up on these main things. First, the value of pi. What's the value of pi? Freeman? It's 3.14. Now, we're going to use 3.14 because we know pi goes on forever. If it's one of these numbers, it's kind of funny to look at. So let's look at it for a moment. 3.14. Does it end there? Let's see. 3.14. 1592. I mean, we know this about pi. It goes on forever. Yeah. No. It doesn't end, and it doesn't repeat. And we call that type of number irrational. So here's a quick example. Pi is irrational. Okay, a rational number is something you could write as a ratio, like 1 over 4. Because the decimal for 1 over 4 is like 25 cents. It's a quarter. And this type of decimal that terminates is called a terminating decimal. We always say terminating decimals come to an end. So if a decimal comes to an end, it's rational. This is rational also, 1/3. Because it is what type of decimal? It's repeating. And a repeating decimal is also rational. So if a decimal ends or repeats, it's rational. And because pi does neither, pi is an irrational number. So we always use 3.14. Okay, we're going to use that as our value of pi. And the other thing is, and let's go back. The other thing is circumference. To find circumference, we use the formula. Brooke, did you know what it is? It's definitely pi times which measure? Did you catch it? Is it the radius or the diameter? It's the diameter. It's pi times d. Now I always think about this thing right here because I use these all the time. You might too. Like a CD, right? CDs are not only circular, but they help me remember that, well, for circumference, you use the diameter, CD. Kind of keep that in your mind because when we do the area of a circle, we're going to use the radius. Okay? So we're always going to use circumference, or we're going to find circumference by doing pi times the diameter. Why do we need to know the radius? Because sometimes, like in this first example, they don't give you the diameter. I think in this first one, they start us off with the radius. So we're going to answer, well, let's see. If the radius is 3, what's the diameter? Joe?
6.
The diameter 6, right.
Oh, that's easy.
It would be all the way across. It would be 3 and 3 more. You guys earlier said it's twice. The diameter is twice the radius, so you would double it. Sonic, can we go backwards then? If we know the diameter is 11, you know the length of the radius? Can you solve this for me? Or how would you find it if you don't know what half of 11 would be? You could divide it by 2. Good. 11, half of, now you could do some estimation like, okay, half of 10, that's 5. Half of 1, that's a half. Very good. It is 5.5, but Sana, we need the measurement. 5.5 what? Inches. Very good. 5.5 inches. Okay? So we're going to use pi times the diameter to find the circumference. So let's do example 3 together. I think you'll get the idea rather quickly if you don't already know. I like to start with the formula. You know, when you find the area of a rectangle or the area of a trapezoid or the circumference of a circle, these things have formulas to help. So let's start with the formula. Circumference equals pi times the diameter. And what's nice then is we're filling in what we know. Okay? Do we know what pi equals? 3.14. So you substitute in 3.14 for pi. Do we know the diameter in this circle? It's what? It's 5 inches. So like algebra, we substitute in the values we know to find what we're looking for, which is the circumference. And what is 3.14 times 5? You got it already, Faith?
15 and 7 tenths.
Excellent. I like the way she said that. 15 and 7/10. We do need a label, though. This is a distance. Joe?
Inches.
Inches. And since I have shown my work, I want to make sure I circle my answer. 15 and 7/10 of an inch. Okay. Now let's skip to number 6, just for a different type of example. It says a builder is putting in a circular garden, and maybe he wants to put a fence around it, because a fence would be like the distance around it. It says find the circumference by rounding pi to 3. Okay, so not every question wants us to use 3.14. If we're going to round, if we're going to estimate, then we could just use simply 3. It says, what is the circumference if the radius is 30 yards? So again, I start with my formula. It gets me on track. It reminds me of the pieces I need to have. Okay? This time, what are we going to use for pi? 3. Now, I remember reading that question. I don't remember them telling me about the diameter. What did they tell us about? Freeman? It says the radius is 30. And Freeman, if the radius is 30, then what's our diameter? Then it's another 30. Very good. It would be 60. So we are sort of estimating here. We're rounding pi to 3, making it a little bit quicker and easier to solve. So what is our circumference? Destiny?
90 yards.
Be careful. Did we use the 30 for the radius, or did we use the 60 for the diameter? So if we correct that, if we edit it, Destiny, let's do 3 times 60. And with an estimate, if you do 3 times 6, very good. And I like the way earlier you put yards at the end. The circumference is 180 yards. Okay? Now in just a moment I want you to do 4 and 5. But let me ask you something. Do you know why pi works like this? Tim and Moby even mentioned it in the video. This cool little number, but they're not sure how it works. I think I know how it works. Best represented maybe in this this little image here. This is called pi unrolled. You can maybe see why it has that name. But if you have a circle that is 1 unit from one side through the middle to the other, called the diameter, what happens every time is if you unroll it, it's exactly going to hit here just after 3. See, measuring the distance around the outside of a circle, I should say a circle is circular. But you could take a tape measure and you could wrap it around a circle, like my stool here. It's circular. And if I wrap that tape measure around the stool, once I have my measure, I could take that tape measure and straighten it out. And that gives me the distance around it. So unrolling a circle is really like finding the circumference. And no matter what circle it is, big or small, this always works. And I kind of want to prove this to you. Okay? I'm going to measure around my stool. And I want to tell you its measurement. Now if I'm measuring around the stool, that's actually measuring what? The circumference, because it's a circle. And Gabe's right here, he can see that. It's exactly 103 centimeters. So what's kind of cool about this always working is if you know the circumference is 103 centimeters, divide by pi, and it'll tell you the diameter. So I want you to divide 103 by 3.14. But I don't want you to tell me the answer. I'm going to predict it. Okay? I'm going to take my tape measure, and I'm going to measure the diameter of the stool, and I'm going to try and describe to you what your calculator says. Okay? Now this is going to be an estimate because your calculator might round to the nearest hundredth, or maybe it goes on to the thousandth. And my ruler only has tenths. So here's my description. Okay? Destiny, she can kind of see how I'm going to predict this. It's less than 33, but it's more than 32 and a half. And if I count those little numbers in between, I've got 32 and 8 tenths. Is that pretty close to what your calculator has? Okay, so every circle, big or small. If you have a circular swimming pool, the distance around it is exactly 3.14 times its diameter. If you take a hula hoop or a basketball rim, they all have the same thing in common. That 3.14 number, really, really neat. Okay? So, back to where we were here. Take a moment and solve numbers 4 and 5. Okay? Take a moment and try 4 and 5. Look for if they give you the diameter or the radius. That's a pretty big starting point. That's why you saw me in number 3. That's why I started with the formulas. I wanted to make sure I was going to use the right numbers. And this would be a little sticking point if you didn't notice. What are they starting us with? What are they starting us with? Tucker, can you help me with this one? What do they start us with? The radius or the diameter?
Radius.
The radius. So, we know pi is 3.14. That's what they told us to use right here. But are we going to multiply by 12? Is 12 the diameter? Robert says no, it's
24.
It's 24. Got to be a little careful there. We need 2 12s because we need to get all the way across the circle. So the circumference, you know what? It's not 75 and 36 hundredths. It's what? 75 and 36 hundredths of a meter. Without a label, I don't think our answer is fully right. As a matter of fact, I know it's not. There's a big difference between a meter, like this big, and a mile. Big difference, right? All right, back to number 5. They're asking us here, I see, to round pi to 3. So pi times the diameter, we're going to use 3. And right here it points out that the diameter is 10. So we're going to use 5 or 20. Jocelyn? You use 10. It told you the diameter is 10. So that's what we're going to use. I mean, we're done. 3 times 10? That's 30 what?
30 feet.
30 feet. Very good. Okay? All right, so with about 12 minutes left, let's start our homework together, because I just want to make sure there's a few things that you need to do correctly. Number 1, I mentioned it earlier. Do you remember how to name a circle? Well, write it down if you do, and we'll see tomorrow. Do you remember how to name a circle? Okay. What I want to look at together is right here, number 3. Okay? You know, what's funny is we talk about a radius all the time. Number 3 says to name 4 radii. You know, and kind of like one goose and many geese, or one mouse and many mice, this is like, well, many radiuses, which that's why they call it radii. And it asks us to name 4 of them. So, you know, maybe I'll just say, okay, 1, 2, 3, and 4. But I want to remind you how to write a segment. So does anybody know how to describe to me the radius? What would you write, Joe?
W.
Starting at W. To what?
W to X.
To X. Very good. So I know this. The segment is called WX. But what I have to put with it is a symbol, a label for segment. Do you know what it is, Nino? Not an angle symbol. We're not working with an angle. If this was angle, yes. John? A line segment above it. Very good. Let me just say this. If WX was a line, we put the line symbol. If WX was a ray, we'd put a ray symbol. Since WX has 2 endpoints, we're going to use this. It's the segment symbol. As John said, it's a line segment. And I do not put dots on the end. Because if it's not an arrow, then we know it ends. And sometimes if you put a dot, it's every once in a while it could look like an arrow. So we just say, you know what, you don't even need that dot. Leave it as a segment. Leave it as open-ended, meaning no arrows. We know it comes to an end. Okay? So, last night we had a few homework problems. Tonight we add these ones, and you've got the rest of the period as it appears to work on your homework.